students, as I told you that in the class we have done sums of stress, strain and Young's modulus. So today basically we will be doing sums of elasticity based on those formulas which you have done in class, which is stress, strain and modulus of elasticity or your Young's modulus. Okay, so let's see the formula. So stress, as I told you, it is force by area. Force is m into g, mass into acceleration due to gravity. Strain is delta L by L, where delta L is the change in length and L is the actual length. Y, which is Young's modulus, is stress by strain, which is stress is nothing but your mgl by A delta L, which I had derived and showed you. Now area is pi r square, so I have divided it and written it mgl by pi r square by L. Another formula, F1 by F2 is called delta 1 by delta L2. Volume is area into length. In case of liquid, any liquid it is, in that case total force is the force which we are giving as well as the buoyant force which the liquid is giving. So it is Fg minus rho gv, because buoyant force Fb you have done in class 9 is equal to V rho g or rho gv. Okay. Now K delta x, in case of spring or some elastic substance given, in that case K is the spring constant, delta x is the extension and mg is the your mass into acceleration due to gravity. Now F, in terms if angular acceleration is asked, okay, in that case force is mr omega square, that is mass into your radius, okay, radius of the wire into omega square. Basically here we will apply m, capital M, for all cases so that you don't get confused, okay, and omega square is the change of your angular velocity. And alpha, which you have done in class 9, is the coefficient of linear expansion. It is delta L by L into delta T. So delta L by L, obviously you are doing in elasticity chapter, you have to remember that. So these are the sums which we will be doing the sums. These are the formulas, okay. So let's start with, so before you start the sums, please refer to page 576 of your Newton's class 11 physics book, okay. So let's start with sum number 1. What is the sum given? It's given a weight of 1 kg is suspended from the lower end. So weight, that means the mass is given as 1 kg, okay, is suspended from the lower end of a cross section 10 millimeter square. That means area is given as 10 millimeter square. As I have already told you before that whenever you are given in millimeter, please convert it into standard unit. Now you know 1 millimeter is 1 by 1000 meter, okay. Now look here, it is area millimeter square. That means it will be 10 into 10 to the power of minus 3 whole square. That means we are getting 10 into 10 to the power of minus 6 meter. Okay. Next it is given, or you can solve it and make it 10 to the power 5 meter square. Okay. So we have converted millimeter square, meter square. Always remember 1 millimeter is 10 to the power of minus 3 meter. So millimeter square will be 10 to the power of minus 6 meter square. Okay. Next, what else is given? Find the magnitude and direction of the stress produced in it. Okay. So G is given as 9.8 meter per second square. What you are asked to find the magnitude of stress. What is the formula of stress? Stress is force by area. Okay. And force is nothing, or area is given to us. Force is directly not given, so we can use the formula m into g. So m is given to you, g is given to you. Just put the area and you will get the answer. And what is the direction of this stress? Stress always acts in the upward direction. Okay. So basically whatever the answer you are getting, it is acting in the upward direction. Okay. Please don't forget to write the proper unit. So please, for all the terms, please use proper units. Okay. As I have told you in the class. Now let's do sum number 2. What is sum number 2? In order to produce a longitudinal strain, okay. So strain is given as, what is the strain given as? 2 into 10 to the power of minus 4, okay. A stress of 2.4 into 10 to the power 7 Newton per meter square is produced in a well. Stress is also given to us. So stress is how much given? 2.4 into 10 to the power 7. Okay, 2.4 into 10 to the power 7 Newton per meter square. Okay. Calculate Y of the material, means Young's modulus. Very easy. So what is the formula of Young's modulus? Stress by strain. You know strain doesn't have any unit because delta L by L gets cancelled and so strain has no unit. Just put it in the formula, get it, solve it, and you get the Young's modulus Y. Okay. Don't forget to write the proper answer. Very easy sum number 2. Let's do number 3 sum. Okay, let's see what number 3 sum is telling us. So number 3 sum is telling a copper wire has a length of 2.2 meter. So L is given as 2.2 meter. Okay. Its diameter is 7 into 10 to the power of minus 4 meter. So diameter D is given as 7 into 10 to the power of minus 4 meter. Okay. What will be the elongation in its length? That means delta L. You have to find out. When a 5 kg weight, that means M is given as 5 kg, is suspended, Y, Young's modulus is given as 1.25 into 10 to the power of 11 Newton per meter square. What else is given? G is given as 10 meter per second square. Okay. So, you have to find out what the elongation produced. That means you have to find out delta L. So, as you can see, obviously all the terms. So, here one thing you have to do, students. As diameter of the wire is given, you have to first find out the radius. How will you find out the radius? You know, radius is diameter by 2. So, if you divide it by 2, you get the radius. I am showing it over here is 7 by 2 into 10 to the power of minus 4. Okay. So, you get the radius over here. Now, you can easily put it in the formula. Y is equal to mgl by pi r square delta L. What do you have to find out? Delta L. So, delta L goes here. So, what do you get the formula? mgl by pi r square y. Just put the values. M is given to you. M is given. Okay. G is given. L is given. Okay. Pi is 3.14. As you know. R square is this value, put it, and Y is also given as 1.25 into 10 to the power of 11. So, all quantities are given to you. You have to find out delta L. Very easy. Just solve it and get the answer. Okay. Now, next sum. Okay. Let's do the next sum. Number 4 sum. Okay. Number 4, it is given. What is given? Let's see. Yes. If Young's modulus for steel is, so Y is of steel, let me write steel, okay, is how much? 2 into 10 to the power of 11 Newton per meter square. Okay, this is given. Then how much weight? That means M you have to find out. To be suspended from a steel wire of length is given as 2 meters, okay. And diameter is 1 millimeter. Again, diameter is given to you. Okay, remember that. So that the length of the wire is increased by 1 millimeter. Increased by 1 millimeter means what? Delta L. Okay, delta L is given as 1 millimeter. Okay, so please convert this millimeters into meters. So that means 10 to the power of minus 3. Diameter also please convert into meter, minus 3 meter. Remember students, if you are not converting all the units in the proper units, then your sum answer will come wrong. So please do the proper conversion before putting the formula and putting the values. Okay. Next, what else is given? Increased, and G is given as 9.8 meter per second square. So you see students, all quantities are given to you. Just put it in this formula and you get the answer. Okay, diameter is given. So what will be radius equal to diameter by 2? That means 10 to the power of minus 3 by 2. Okay. So just put it in the formula. So Y is equal to mgl by pi r square delta L. Okay. All quantities are given. You have to find out M. So M will be equal to Y pi r square delta L by GL. Okay. So put all the values, solve and get the answer. Okay. So it's also an easy sum. Now let's do the next sum. Number 5 sum. Okay. So these sums are easy if you know the formula. Okay. Now number 5 sum. Number 5 sum, it's given that if the length of a wire increases by 1 millimeter under 1 kg. That means L1, suppose it is 1 millimeter. Okay. It's looking like 4. L1 is given as 1 millimeter under mass is given as 1 kg. Okay. So you can convert it into meter, 10 to the power of minus 3 meter. Let us be in the safe side and let us convert it. Okay. What will be the increase under 2 kg? That means you have to find out L2. M2 is given as 2 kg. Okay. Now G, you can take it as G, you take it as 9.8 meter per second square. Okay, but you will not utilize it over here. So here, as you know, see, F1 by F2 is equal to delta L1 by delta L2. This is delta L1 because there is an increase. Okay, so delta L1 by delta 2. So just put it in the formula. F1 by F2 is equal to delta L1 by delta L2. Okay, what you have to find out? You have to find out delta L2. Now, what is F1 equal to? It is nothing but M1 into G. Let me write it as capital because I am using capital always. And M2 G. So, here you see you are not requiring this G value because G gets cancelled. So, what is the equation becoming? Delta L1 by delta L2 is equal to M1 by M2. Put the value, solve, you will easily get delta L2. There is another part also. Same way, they have asked what will be the weight, what will be the extension under 100 kgs. Here, if the weight is 100 kgs, what will happen? It will break. It cannot bear a weight of 100 kgs. Okay. So under 100 kg, the wire will break off. Okay. Next, number 6 sum. So just remember this formula when you are doing this type of sums. Okay. Number 6 sum. Let us see what number 6 sum is telling us. Number 6. Number 6 sum says, okay, number 6, yes. The length of a wire increases by 1%. Okay. So let the original length be L. Okay. So what is happening? It is increasing by 1% when on loading a 2 kg weight on it. Okay. So when we are putting a load of 1 kg, okay, what is the mass of the body given? It is given 2 kgs. Okay. So let the length be L. Okay. So what will be the new length? L dash. It is given that it increases by 1%. That means L dash will be equal to L plus L by 100. Okay. 1% means L by 100. Okay. That means how much it is coming? 101 by 100 L. Okay. Which is equal to, from the back if you do 1.01 L. Okay. 1.01 L. So now they have asked that calculate the linear strain in the wire. Okay. So how will you find delta L? So delta L is nothing but L dash, the new length after increase of 1% minus L. So from here you will get delta L. Okay. And actual length, you know, it is L. Okay. So after that, so they have asked strain. So strain is nothing but delta L by L. So from here you are getting delta L. Here the original length L is given. So just put it, solve, and you'll get the strain. Okay. Now let us do the next sum. Okay. Let's do the next sum. So let's see what number 7 is telling us. Number 7 sum tells us. Number 7 sum tells us that the length of a wire increases by 8 millimeter. So length increases by 8 millimeter. Okay. When weight of 5 kg, that means mass is given as 5 kg, is suspended from it. If other things remains same, but the radius of the wire is double. So let us take R1 as R. Okay. So what will be R2? 2R, because the radius is getting doubled. Okay. So what they have asked, what will be the increase in its length? Okay. So they have asked the increase in its length. Okay. So we have to find out that when the radius is doubled, what will be the increase on the weight? Remember, mass is constant. Okay. So you know that stress. Okay. Here we have to use the formula Young's modulus only. What is the formula of Young's modulus? It is stress by strain. Okay. And what is this stress? It is nothing but F by A. Okay. By strain is delta L by L. Okay. So what you have to find out? You have to find out the increase. Means you have to first find out the force, and from there you have to find out what is the what will be if the radius is doubled. Okay. So y is let y, keep the y as it is. We will utilize because we have to find out another condition when the radius is doubled. Okay. So what is the formula of y becoming? If you cross multiply, y is equal to FL by A delta L. Okay. So what is F equal to? Y A delta L by L. Okay. So what is the value of delta L? 8. Okay. So y keep it as it is. okay, or you can do F by you can keep Y as it is, okay. Length you don't know, keep it as L only. A is pi r square, so this one will be pi r square. That means here it becomes F. So F is given as so sum number 7. So these are the quantities given to us. Okay, it's told that R1 is R and R2 is, the second radius is doubled. It becomes 2R. Okay, so you know Young's modulus is stress by strain. What is stress? F by A. And what is strain? It is delta L by L. And Y, keep it as it is. Okay, so if I multiply, cross multiply, so what am I getting? Y delta L by L is equal to F by A. Okay, now what is force? F is nothing but m into g. What is the value of m? 5. Take g as 10 meter per second square. Okay, so what is the force you are getting? 5 into 10, which is 50 Newton. Okay, so put that force over here 50. Let the area be as it is. And here, instead of delta L, put it as 8. See, it's given 8 millimeter. Okay, you can convert it into meter also. Okay, 10 to the power of minus 3, as we do 10 to the power of minus 3. Okay, by L. Keep this term as it is. So our expression is coming Y 8 into 10 to the power of minus 3 by L. Okay, let me write it properly. 8 into 10 to the power of minus 3. Okay, by L is equal to 50 by A. Now, this is the first equation. Again, same putting the, again under the same formula, we will put the second equation. Now, Y delta L. Okay, let us take that change be L dash. Okay, when the radius becomes double, let the length, increase of length be L dash. So L dash by L is equal to, what is the area? Okay, m into g only, because area is, because they have told mass is constant. So it is 50 by, now area, here see radius becomes 2r. So what will be the change of, what will be the area over here? 4 pi r square. Okay, so keep it as 4a. So your area becomes 4a. This is the second equation. Okay, so now solve these two equations. Okay, if you solve this two equation, rest of the quantities will get cut out and you'll get the value of L dash, which is required. So basically here you have to find out L dash, the increase in the length when the radius becomes 2r. Okay, so please solve this equation 1, equation 2, just divide it and you'll get the answer. Okay, so please solve these two equations and get the answer. Okay, now let us go to the 8th sum. Let us see what the 8th sum tells us. Sum number 8. Okay, sum number 8, it tells us that if Young's modulus of steel is 2 into 10 to the power of 11 Newton per meter square. Okay, so Young's modulus of steel, let me write as steel, is how much? 2 into 10 to the power of 11 Newton per meter square. Okay, now then how much weight is suspended from a steel wire of length 2 meter? Okay, so length is given as 2 meter. Okay, diameter is given as how much? 1 millimeter. 1 millimeter, as you know, it is 10 to the power of minus 3 meter. Okay, so that the length of the wire is increased by 1 millimeter. Okay, so here the length of the wire is getting increased by 1 millimeter. That means delta L is given as 1 millimeter again. Okay, so 1 millimeter means 10 to the power of minus 3 meter. What else is given? G is given as 9.8 meter per second square. Okay, so everything is given to us, Y, L, and this is the diameter. So as diameter is given to you, please find out the radius. How? By 2. So if diameter is this, R will be 10 to the power of minus 3 by 2, because radius is diameter by 2. What you asked to find out? You are asked to find out what the it is. You have to find out the m value. Find the mass. Weight means the mass you have to find out. Okay, so you know here the formula or everything is given. So you know Y is equal to mgl by pi r square delta L. So delta L is given, L is given, Y is given, G is given, and R we have got it. So put the value, remember pi is 3.14. Okay, so just let us make the formula. So m will be equal to Y pi r square delta L by GL. Okay, so put these values, solve, and you'll get the mass of the substance. Okay, what is the mass or what is the weight? It must be suspended. Okay, Now let us do the ninth sum. Okay, ninth sum. Let us see what ninth sum is telling us. Sum number 9. Okay. Sum number 9 tells us that a composite wire consists of a steel wire of length 1.5 meter and copper. So there are two wires. One is suppose length of steel wire. Okay, let us write steel is 1.5 meters, and there is also a copper wire of length. Suppose I will write CU 2 meter. Okay, and with a uniform cross sectional area of 2.5 into 10 to the power minus 5 meters square. That means area is same, which is 2.5 into 10 to the power minus 5 meters square. Okay, what else is given? It is loaded with a mass of 200 kg. Means on both of them the mass is 200 kg. Okay, now find the extension produced. Okay, you have to find out the extension produced. What else is given? Y of copper. Young's modulus of copper is 1 into 10 to the power 11. Okay, Newton per meter square. And what is the Y of steel? It is given as 2 into 10 to the power 11 Newton per meter square. Okay, and G is given as here. Let me write G over here, 9.8 meter per second square. So what you have to find out? You have to find out the delta L. Okay, remember there are two loads over here. Okay, sorry, there are two substances, two strings. Okay, one is steel and one is copper. Okay, so how will you find out delta L? So for that, students, delta L is nothing but you have to find out. Okay, first you find out the delta L of copper. Okay, by using this formula, Young's modulus formula. Okay, you can use this formula because area is given to you. So delta L is nothing but your, I'm directly putting it in the formula, students, mgl by A into Y of copper. Remember copper, okay, because mass is constant for both of them, it's same. L is L of copper. Let me be specific. L of copper, okay, so that you don't get confused. L of copper is different. Area is same for both of them, okay, and Y of copper. So you are getting delta L of copper. Again, to find delta L of steel, you find out again mgl. Remember mass and the mass and area is the same for both, okay, into Y of steel. Here length of steel. So solve delta L of copper, delta L of steel, and then you add it. Okay, so to find out the total length, you have to add copper, delta L of copper plus delta L of steel. Okay, so if you add the delta L of copper and delta L of steel, what will you get? You will get the total extension produced. Okay, students, so this is sum number 8. Now let us find out the sum number. So is it clear? Just you have to individually find out the extension in copper, extension of steel, and then add the two extensions. Okay, remember mass and area is the same in both the cases. Okay, now let us do sum number 9. Okay, let us see what sum number 9 is telling. Okay, sum number 8. Okay, no, sorry, sum number 9 is done. Let us do sum number 10. Let us see what sum number 10 is telling us. Okay, 10 is telling that a rod AD consists of 3 segments. Okay, suppose this is a rod AD, A, D. Okay, there are 3 segments. B, this is AB, BC, CD. Okay, so AB, BC, CD. These are the 3 sections. Is hanging vertically from a fixed support A. Oh, it's hanging vertically. Okay, so this is the rod AB and it is hanging vertically. Vertically means like this. So this is from here, it is hanging A point. So A and D point. This is the B point and this is the C point. These are the 3 segments. What they have asked, the lengths of the segments means this one is 0.1 meter. This one is how much? 0.2 meter. And the other one is 0.15 meter. Okay, so these are the lengths of the segment. What else is given? The cross section of the rod means it is uniform. That means A is given as 10 to the power minus 4 what? Meter square. Okay. A weight of 10 kg. That means M. So here a weight of 10 kg is hung. Okay, from D. So let us write mass is given as 10 kg. Calculate the displacement of point B, C B, C and D. Okay. So Young's, now neglect the weight of the rod. You have asked to neglect the weight of the rod, means M is negligible over here. Okay. So here means Y of AB. Okay. So remember, these are the three segments. Y of AB is given as 2.5 into 10 to the power of 10 Newton per meter square. Okay. Y of BC is 4 into 10 to the power of 10 Newton per meter square, and Y of CD is 1 into 10 to the power of 10 Newton per meter square. Okay. So you are asked to find the increase. Okay. Calculate the displacement of point B, C and D. Okay. So first we have to find the increase of the point B. Okay. That means delta L. You have to find out for B point. Okay. So how will you find out? See, Y is given to you. So let us put it in this formula. So mg L by A into Y. Okay. mgl, L means L of AB. Okay. So L of AB is given to you. I have not written it. Please look at the diagram for understanding. L of AB to find out delta LB. Okay. So putting this formula, AB, this is YAB. Okay. So you know mass is given as 10 kg. Take G as 9.8 meter per second square. Okay. So you can take 9. If it is not specified, you can use 9.8 meter per second square. If you take 10 also, there will be difference of point in the point. Okay. So don't worry for that. You can take G value as anything. So just put it over here. Everything you know, M you know, G you know, LAB you know, which is 0.1 meter, and A you know, YAB you know. Just put it and get the displacement of B. Now, increase in segment of BC. Okay, to find out the increase in segment of BC. So delta BC. Okay, so to find out the increase, oh, this one we have found out AB. Now we are finding BC. Same way, MGL BC by A into Y BC. Okay, just put it. Remember, BC is 0.2 meters. Okay, length of BC is 0.2 meters. And YBC is given to you. Mass is same, G is same. Just put it and get the answer. Next, delta L. Next, they have asked CD. CD, similarly, you find out MGLCD. Okay, by A into YCD. Okay, so you know all the formulas. First, find out the your displacement of AB, AB, BC and CD. After that, now they have to find out the displacement of B, C and D. So what is displacement of B? It is this, nothing but this one. What is the displacement of C point? See, when you're finding the displacement, what you have to find out? You have to find out the AB. You have to add the AB portion plus the BC portion to find out the displacement of C. Okay, because C is connected with AB and A is connected over here. So to find out CD, okay, displacement of C, you have to find out delta L of AB plus delta L of BC. Okay, so if you find out this two extension, then you will find the displacement of C. Now, to find the displacement of D, okay, so you see D is the last point. That means the whole extension is included over. That means you have to add delta L of AB, okay, plus delta L of BC plus delta L of CD. Okay, so remember that to find out the displacement of B, it is nothing the first point, so it's very easy. C means it is connected with A, so AB plus BC, and to find out D, AB plus BC plus CD. Okay, so you do it and you get the displacement of B, C and D. Okay, now let us go to sum number 11. Okay students, so see, the sums are very easy. Same formula we are using over here, only you have to see which formula is correct for that one. Okay, now sum number 11. Sum number 11, it's told that a piece of metal of 2 kg weight, that means mass is given as 2 kg, is suspended from one end of a vertical wire whose other edge is fixed, and the piece is fully immersed in oil. That means rho of oil is given as, density is given as 0.7 into 10 to the power of 3 kg per meter cube. Okay, so this is the density given. Okay, next, the length of the wire increases by 1 millimeter. That means delta L is 1 millimeter, which is 10 to the power of minus 3 meter. Okay. If the diameter of the wire is 0.6 millimeter, D is given as 0.6 millimeter, that means 0.6 into 10 to the power minus 3 meter, and radius, obviously diameter doesn't have any work over here, so we have to find out the radius. So by 2 into 10 to the power minus 3 meter. Okay. Next, what you have to asked, Young's modulus. Obviously Young's modulus of the wire is given as 2 into 10 to the power 11 Newton per meter square. Okay. And the volume, obviously volume is given as 800 centimeter square, a centimeter cube. Okay. Now students, as it is given in centimeter cube, please convert it into meter cube. How about have 800 by 10 to the power of 1 meter is 1 centimeter is 1 by 100 meter. That means 10 to the power minus 2 meter. So cube will be 10 to the power minus 6 meter cube. Okay. So we have done it. Okay, so not 10 to the power minus 6, 10 to the power 6 by I have written. So 10 to the power 6, when it goes up, it becomes minus 6. Okay. Now, what you have to find out? You have to find out, calculate the initial length of the wire. L you have to find out. Now see, in the beginning of the, before I had done the sum, I told you that whenever liquid comes, okay, if in case of liquid is given, the wire is put in the liquid. So in that case, two type of force act. One, which one we are putting it down, and the buoyant force given by the liquid. Okay, here the liquid is the oil. So F, what is the force over here? It is not only F, it is the F minus the FB. Okay, so F minus the FB. Take G as 10 meter per second square. Okay, you can take it as 10 also. So what will be F equal to? It is nothing but F minus FB, which is mg minus V rho G. Okay, so in case of, whenever it is given in case of liquid, please use this formula, the downward force with the force which we are putting the body downwards, and the upward force given by the buoyant force. Okay, so mg minus V rho G. Okay, now so it becomes easier. So L we have to find out. Okay, so what is our formula? Y is equal to mgl. Okay, or rather I will not write mgl, rather I will write fl. Okay, because here the force is different. FL by A into delta L. Okay, so we have to find out L. So what is the formula coming out as? L is equal to YA delta L by F. Okay, here F is mg minus V rho G. So Y is given, area you can find it out over here. How? Pi r square. Okay, so let me specify pi r square into delta L is given over here. Okay, everything is given. Now F is what? Mg minus V rho G. See, volume is given, density is given, and G I have already told 10. Okay, just put it in the formula, solve, and you'll get the actual length L. Okay students, so this was sum number 11. So remember, in case whenever a substance is put in a liquid, two types of force, the force with which we are putting the body in the liquid, and the force given by the liquid, which is the buoyant force. Okay, which you have done in class 9 also. Buoyant force is VOG. Okay, so now sum number 12. Let us do sum number 12. Let us see what sum number 12 tells us. Okay, sum number 12. Sum number 12, it tells us a weight of 20 kg, so mass is given as 20 kg, okay, is suspended from a wire. The area of cross section of the wire is 1 millimeter square. That means A is 1 millimeter square. Again, millimeter square means 10 to the power of minus 6 meter square. Why? Because 1 millimeter is 10 to the power of minus 3 meter. So millimeter square means 10 to the power of minus 6 meter square. Okay. Next, what is given? When stretched, the length is exactly 6 meter. Okay, so length is 6 meter. Means when it is stretched, remember, stretch means it is delta L. When the weight is removed, the length reduces to 5.9. So obviously, when you stretch the wire, then only the length increases. Okay, that means the original length is 5.995 meter. So delta L. So see here, they have not given you the elongation, nothing. They have told you. So you have to use your concept. Obviously 6 meter cannot be 5.9 because when a body stretches and you remove the body comes back to the original length. Okay. So that means the original length is obviously smaller than the stretched length. So delta L is 6 meter. Okay. So basically not 6 meter. This is L dash. Sorry, it's not delta L. We have to calculate delta L. L dash. What is L dash? Means the length when it is stretched. So you will find delta L how? L dash minus L. So subtract 6 by 5.995, you'll get delta L. What else is given? When the weight, calculate the Young's modulus of the material. Why we have to find out. Okay, so it's a very easy sum. So just put in the formula y is equal to, take g is equal to 10 or 9.8, whatever. Okay, see what in your book, what is the value is given. If it is not given, you can use 9.8 and 10. Again, I'm telling you, if you use 10 also, the sum is correct. Okay, only there will be difference in the decimal, not in the main position. Okay, so y is equal to mgl by, what is the formula? A delta L. So see, m is given, L is given, delta L we have found out, and L is obviously 5 this. Put the value, solve, and you get the Young's modulus. Very easy sum. Okay, just you have to figure out the sum, students. If you can figure out the sums are really easy. Only just you have to apply your concept when you are doing this sums. Okay, now sum number 13. Okay, let's see what sum number 13 gives us. Sum number 13 is basically based on this formula. Okay, the length of a rubber cord, okay, like a spring, increases to 60 centimeter under weight of 100 gram. Okay, so all are in a CGS unit. So let me keep it in CGS unit only. So what is it is given? L1. Let me write it as L1 is 60 centimeter. Under weight M1 is given as 100 gram. What else is given? Suspended from it and to 70 centimeter under weight of, so L2 is 70 centimeter, under weight M2 is given as 120 gram. Okay, so let us take the original. Let original length be L. Okay, original length is equal to L. Okay, this is the when it is increasing. Let us take the original length as L. Okay, so what is delta X? Delta X is the increase. Okay, it is the increase in the length. Okay, so our formula, let us first look at the first length. Okay, so here K, okay, suppose we have taken the length as L. Okay, let us take the length as, original length as L. Obviously it is extending, means this is bigger than this. So L1 minus L, change of length, is equal to mg. What is M1? It is 100. Keep g as it is because anyways it is going to cancel out. Okay, now what is the second? This is equation 1. Okay, let us find out equation 2. Similarly, what will be L2? L2 minus L is equal to 120 gram. G. Okay, now if you divide 1 by 2, if you are dividing, okay, 1 by 2, you'll get the value of L because L1 is given to you. That means K. Okay, what is L1? 60 minus L. Okay, by K, 70 minus L is equal to 100G by 120G. Okay, GG gets cancelled, KK gets cancelled. Now you can solve and get the value of, you will get the value of L from here. Okay, once, so you have got the value of L. Once you get the value of L, so you have got the actual length. Next, also calculate, so this is the initial length, one answer you have got. Now they have asked, also calculate the weight under which the length of the cord will become 74 centimeter. So next the third length is given to you. Okay, so I'm wrapping this portion. Please put the values. Okay, so in the third case, they have asked you to find the value of the weight M. They have asked you. Okay, so L you are getting the answer. Okay, so L3 is given as 74 centimeter. Okay, now you have to find out. Now students, as you have got the value of L, okay, L1 you know, so put it in this value. L1 you will get L1 is given as 60, L you are finding out, okay, is equal to 100 into 10. Okay, now when you are using 10, that means you have to convert this also, okay, by 1000. Because G is 9.8 meter per second square. Here we have taken as gram. Okay, here the units were same, so I have not converted it. But to find out K, you have to convert it. Take this as 100. Okay, so L3, L also, whatever you get, divide by 100. Okay, so here you will get the value of K. Please convert the units. Okay, so here you are getting the value of K. After finding the value of K, you know K, you know L. Okay, you can easily put in the formula K. L3 minus L is equal to M into 10. Okay, so you have to find out M. From here you are getting the value of K. You know the value of L. obviously beforehand only. L3 is given as 74. Solve it and you get the answer for M. Okay, so here you have to find three things. One is the initial length which is asked for you. Another, putting in any of the equation, put it in 1 or in any 2 also. Anywhere you put it, you will get the value of K. Okay, so you are finding K. After finding K, you have to find out M. Okay, K and L, if you find out, M becomes easier. Okay, so this was sum number 13. Let's go to the next sum. Let us see what is the next sum telling us. Okay, sum number 14. Now, sum number 14. Sum number 14 tells us, okay, a substance breaks down by a stress of. So, stress is given as 10 by 9 Newton per meter square. If the density of the substance, rho, is given as 3 into 10 power 3 kg per meter cube. Okay. What else is given? Find the length of the wire made of the same substance. L you have to find out. Okay. By which it will break under its own weight when suspended. Okay. So, what is the formula of stress? Stress is F by A. Okay. Force by area. So, is the area given to you? If the density of the substance, no, area is not given to you. Okay. So, nothing is given. Only stress is given, rho is given and L you have to find out. Okay. So, how will you do it? Now, what is the formula of force? Force is M into G, right? By area. Now, again, what is M equal to? Mass. Density is equal to mass by volume, right? Rho, density is mass by volume. See, density is given to you. So, let us bring it in density form. So, if density is mass by volume, what is mass equal to? Density into volume. Okay. That means V into rho into G by A. But we know rho, we know G. Area and volume you don't know. So, how will you find out? Now, again, you know, I have already written volume is area into length. So, basically we are reducing, means we are bringing it into a standard formula where we can apply. So, we can write it as area into length into rho into G by A. So, you see, each term is connected with each other. A gets cancelled. Now, all these terms you know and stress also you know. You can easily find out L. Okay. So, what will be L equal to? It is equal to stress by rho into G. Okay. So, see, all formulas, I used to tell you in the class also, students, from whatever you're learning in the class, in physics, all, I mean, till the time you learn physics, all are connected with each other. So, you have to remember all formulas. See, from one formula, from this formula, we have come to a different formula. Okay, students. So, you know stress, you know rho, you know G. Put it, find out L. Okay. Now, sum number 15. Let us do sum number 15. Okay, sum number 15, it's given that for steel, the breaking stress is 8 into 10 raised to 6 Newton per meter square and the density. Oh, it's the same type of sum like sum number 14. So, please do sum number 15 for yourself. Okay, sum number 15, you have to do it yourself. It's just like sum number 14. Okay. Now, coming to sum number 16. Okay. A body of 10 kg, that means mass is 10 kg, tied at one end of a 0.3 meter wire, that means R is 0.3 meter, okay, is rotated in a horizontal circle. The area of cross section of the wire is, area is given as 10 to the power minus 6 meters square, okay, and the breaking stress, again the stress is given as how much? 4.8 into 10 to the power 7, 7, okay. So, by how much? Or Newton per meter square, it's given by how much maximum angular speed. Okay, omega you have to find out. Can be the body be rotated? Means you have to find out omega. Now see students, what is the formula of F I have written? F here means, let us start from beginning. So stress is what? Force by area. Okay, what you have to find out? Omega. Stress is given, area is given. Very good. Now force, I have already written in terms of force. If you go in terms of omega, it is mr omega square. So we can easily break stress is equal to mr omega square by area. See, m is given to you, r is given to you, omega square. So what will be omega square equal to, or omega equal to? It is stress into area by m into r. Okay. Put it, solve it, find the square root and you get the answer. Okay, so remember F is equal to mr omega square. Okay, in terms of angular velocity. Now let us do sum number 17. Let us see what sum number 17 tells us. Okay, sum number 17. What is 17 telling us? A metallic wire has a radius. So R is given as 0.2 millimeter. Okay, so millimeter, let us convert into meter into 10 to the power minus 3 meter. How much force is required to have an increase? That means the increase of 0.2% in its length. Okay, so if I take the original length as L only. Okay, so what will be the 0.2% increase in its length? Okay, so that means L dash will be 0.2L. Right? Now, what they have asked? They have asked Y. Oh, Y is given as 9 into 10 to the power how much? 10 Newton per meter square. Okay. Now, what you have to find out? How much force? F you have to find out. Okay. So, F, what, Y. So, Y, what is the formula of Y? F into L by A into delta L. Okay. F you have to find out. What will be the formula of F? F is nothing but YA delta L by L. Okay. Now, how will you get delta L? Nothing. L dash minus L will give you delta L. Okay. So, area you can find out because radius is given. So, area will be nothing but pi R square. Okay. So, find out the area. Okay. So, Y you know, area you know, delta L you are finding out. Okay. L you can, L you keep it as L because here also you will get in terms of your means L only. Okay. So, L will get cancelled. So, you can easily find out force. Okay. Only one formula of Young's modulus and you get the sum. Okay. So, this was sum number 17. Now, let us do sum number 18, 19, 20, then finish off. Okay. So, sum number 18 now. So, what is sum number 18 telling us? Okay, sum number 18. Yes. If a stress of 1 kg weight, stress is given as 1 kg weight, okay, per millimeter square, complicated, is applied on a wire, then what will be the percentage increase? That means you have to find out delta L by L percentage. Okay, percentage increase. In the length of the wire, Y is given as how much? 1 into 10 to the power 11 Newton per meter square. Okay, and it's given 1 kg weight is equal to 9.8 Newton. Okay, so these are the quantities given to you. Now, what is the formula of Y? Y is nothing but stress by strain, right? In the beginning only I have written. Now, what is strain? So, what is, let stress be as it is because stress value is given to us and strain is delta L by L. Okay, so what is delta L by L equal to? It is nothing but stress by Y. Okay, we have to find the percentage of delta L into 100. So, just delta L by L into 100. Okay, is equal to, just multiply both sides by 100 and you get the percentage. Okay, now let me show you the conversion of stress. Now, stress is given as 1 kg weight per millimeter square. Okay, so 1 kg weight is how much Newton? It's 9.8 Newton. Okay, now millimeter square means meter square we have to convert. That means into 10 to the power minus 6 meter. Okay, so 9.8 into 10 to the power minus 6 meter. So, I have converted into Newton per meter square. Okay, it's meter square rather. 10 to the power minus 6, 9.8 into 10 to the power minus 6 Newton per meter square. Okay, so I have converted it. So, now just put the values and find out delta L by L. Delta L by L into 100 you get the percentage. Okay, so this was number 18 sum. Very easy. Now, number 19. Okay, let us see the number 19 sum. Let me tell you before I start with sum number 19. Students, sum number 19 and 20 is exactly the same type. So, I am going to do sum number 19 and 20. You are going to do it yourself. Okay. So, sum number 19. A wire of length 1 meter. So, length is given as 1 meter. Has area of cross section. A is given as 0.1. centimeter square. Obviously, please convert it into meter. So, centimeter square means 0.1 into 10 to the power of minus 4 meters square, because 1 centimeter is 10 to the power of minus 2 meter. So, square is given, so 10 to the power of minus 4 meters square. Okay. The Young's modulus Y is given as 2.5 into 10 to the power of 11 Newton per meter square. Okay, this is given. And coefficient of linear expansion, that means alpha is given to you. So see, class 9 studies is coming now. So alpha is given as how much? 2 into 10 to the power of minus 5 degrees centigrade. Okay, per centigrade. The wire is clamped between two rigid support and its temperature is decreased by 10%. That means delta T is 10 degrees centigrade. What do you have to find out? Tension. Tension is nothing but the force F. Okay, you have to find out F. So let us put the formula. So what is my Young's modulus formula? It is mg L by A into delta L. Okay, A into delta L. Now here a temperature is also asked you. Okay, so here since they have asked force, let me put it at F only. Okay. Now what is coefficient of expansion? See, I've written alpha is nothing but delta L by L into delta T. Okay. So if you get delta L by L, so it will be alpha delta T. Okay, in terms of coefficient of expansion. So let us put this value over here. Okay. So Y is given to you. So L by delta L is given, but we have to bring it in terms of delta L by L. Okay. So just reverse it. So delta L by L. That means we are just reversing it. Is equal to if this goes here. Okay. So ultimately you're left with, let me simplify it and then let's do it. So it is Y A delta L is equal to F into L. Okay. So L by delta L. Okay. That means this is up. Is equal to Y A delta L is already there. Okay. Let me reverse it. So delta L by L is equal to, because we have to, it's given. So F by Y into A. Okay. So delta L by L is nothing but alpha into delta T. Okay. So because coefficient of expansion is given to us. Okay. So here the formula becomes, let me put it in the formula. So delta L by L is nothing but alpha delta T. Alpha delta T. Because alpha is delta L by L into delta T. Okay. So alpha delta T is equal to F by YA. Okay. So F is equal to nothing but Y into A into alpha delta T. Okay. Just put it in the formula, solve, and you get the answer. Okay. So remember, alpha is the coefficient of linear expansion. It is nothing but change of the length. Okay, means whenever the length is increasing. Okay, so L dash minus L, that is delta L by original length into delta T, which you have done in class 9. Okay, so obviously delta L by L is nothing but alpha delta T. So we have got this from this equation. Okay, so F is equal to Young's modulus into area into alpha delta T, because alpha and delta T is given to you. Just put the values and solve and you'll get the answer. Okay, same way sum number 2 is exactly the same. Okay, so sum number 20, students, you're going to solve it yourself. Okay, please solve the sums yourself. So this is your 6th assignment. Okay, you have to do all the sums and send me in Google Classroom. Hope students, you have understood the sums. The rest few sums, 8-9 sums which are left, okay, based on your bulk modulus, modulus of rigidity. Okay, I'll be doing the videos and sending you the sums, and we'll finish up with the elasticity chapter. Okay, students. So bye students, take care.